Alright, back again. I'm actually restarting this video even though I got halfway through doing it before, which was a bad choice, but had to do it. So anyway, we're going to be looking at this thing today. And before I go into what this is, we're going to look at a calculator first. So this is a calculator. I was going to say, so when I was a kid I had calculators that were a bit like this one, which... well, not like this one. I just got this one because I thought it was kind of cool that it was a keyboardy thing. But they only have like simple functions, and when you you made a mistake, you have to just clear the whole thing and start again. But then calculators got a little bit fancier, and then they got a delete button. So if you turn this one on, you can put some numbers in, and then you can press delete, and they go away. So when you're young, the obvious thing to do when you have this opportunity now to delete characters on the screen on your calculator is to turn it into a game. And so the game would be, you start with so in the old days you only could type 5 characters on the screen at once, or 10 numbers on digits on the screen at once, but in this case you seem to be able to enter as many as you want pretty much. Such is the way of modern technology. But say you could only do 10, so this kind of goes up to where that little D is. We start in the middle, so there's 5 5s, and one person's on the delete button and one person's on the 5 button, and the aim of the game is to sort of like compete against each other. And so the delete person wants to get rid of all the 5s, and the 5 person wants to get 10 5s on the screen, so get all the way up to the side of the screen. And so the winner is, starting from the middle point, who can get to their side the fastest, right? So that's of course how you use calculators when you're younger, because you wouldn't use them for calculating. That would be a horrible idea. So that's the idea behind this. So I thought, well, I'll make one of these things as an electronics project, and so I kind of want to do it with logic circuits, because I think that would be kind of a good challenge to do something that seems quite computational, but to do it purely basically with logic ICs. But we'll start off and we'll do it with an Arduino first, which is much easier. Though as you'll see, I've coded it in a way that I think will reflect somewhat how I'm going to do it with logic ICs. So we'll turn it on and we'll see how it works. So it starts off, in this case I've got 9 LEDs, so it's slightly different, and it starts off with only one LED lit, and you have to get, if I press the button, it goes each way. It's not exactly perfect, so one press should get you to the end. One press should only move you one LED. So if I press, you can see that's actually not very good. It's a bit bouncy there. But we're going to talk about this in a minute. But hopefully what should happen is I press once and it moves once. I press again and it moves. And I press again and then it moves. I press again and it moves. But you see it double jumps sometimes, so it's not exactly perfect. But that's okay. So the problem here, I believe, is because there's button bounce. I can't remember what the actual term is, but you have to debounce things usually. Because what will happen is the button will, when you let go of it or you press it down, it will actually vibrate. So that's actually what is happening. So when I let go there, sometimes it will shift along. It won't actually do it as much as it could do because I've coded it in a certain way. So there you go. When I let go of the button would actually vibrate a couple of times and knock back down again and just create a contact very briefly, but enough to tell this thing to trick into thinking that the button was pressed again very quickly. So of course what you can do is just check to see that the button was held down for at least a certain amount of time before going up again, or things like this. So there's many ways of sort of coping with this so that you can detect if it's a bouncing event, which is a very fast one, as opposed to an actual thing. But I don't really want to have to worry about that in the logic version. So in this version I haven't kind of done it, but I've kind of made it so that it's not a big issue and it should apply to both sides equally. So in the end you're going to be doing this. You don't really have to worry about it. If this one's got a bit of contact bounce, that's what it's called, then the other side will also have that, and so it will balance out, as my theory in this case here. But anyway, you get to the end and then you have to go a little bit further, and then it flashes a couple of times and then it goes back to the middle. So I don't know what's going to happen in the logic version. It's probably not going to flash a couple of times. It might make a beep sound, or a little light will come, a little red light or something will come off to the side. I think making it flash 4 times, for example, is just going to be too much effort. But it will do something similar, and then it will reset back to the middle. So most of this behavior, I think, should be in the final logic-based version. But that's the thing. So let's just quickly have a look at the code. And I'll cough first. So the code is actually quite complicated, and it has some interesting features of C in it. So I don't know how I'm going to go about going through everything. So the first thing is, this is the setup code here. So I don't know how well it looks. It's a bit hard to read upside down. I tried to get the font as big as the most appropriate size font. Hopefully it's readable on the screen. Did I get a bigger font version? I printed it out several times. No, this is actually the larger font version. Probably could have gone way out and made it really, really big. Or maybe we'll just zoom in a little bit. And we'll start at the top here. It's always a bad idea when I zoom in on the camera, so I probably shouldn't have done that. So here I've just got some constants. The first one is the first LED, so I've just arranged them all so they're on the pins, they're all in order. So the first pin is pin number 2, so I've missed out pin 0 and 1 because those are the serial port connected pins. And then I've got 9 LEDs, and then I've got the lower button. I'm using the analog inputs for the buttons. And then I've got some other things here which will come in later. So those are just constants for defining the end flash. And then we've got the movement update rate, and this is going to be important, and we'll come back to this in a minute. But this is how I've done it, slightly different to what you might expect, because you might expect me just to be sitting there waiting for me to press the button. So the code should be saying, if you press a button, move. If you press the other button, do that, and just do that really, really fast. But in fact, you're going to see that I do this only on certain occasions. And this is because it's going to play into how I intend to do this in the final version. So here we've got put your code here. Did I not remember to take out that comment line? Apparently I forgot to take that out. I forgot to check this is still on the screen. It is. Right. So here I've just got a little simple loop that's just setting up all the LEDs to be outputs. That's pretty obvious. And I'm just setting the buttons to be inputs and pull-ups. So they're using an internal pull-up. So if they're not being pressed, so the buttons are pulling it to ground. So on here, the buttons just pull it directly to ground when they're pushed. They don't pull it to a high voltage. So by default, they're high, and when you push the button, they're low. So that's the setup done. So that's very straightforward. So here I've got a set position thing. So I've written it in a very strange sort of way. This thing here, this is not going to be translate at all to the digital version. So the digital the logic-based version is going to be looking at this sort of like in some ways completely flipped around. And instead of looking at it holistically from the whole thing, looking at it from the point of view of each LED. But here I'm just saying, well, I have the set position function, and that just takes the position, and then it just sets whatever LED you want on to be on. So if I pass in 0, then the first LED will be on, and if I pass in 8, the last LED will be on. Actually, in this case here, if I pass in 9, then no LEDs will turn on, and it will work fine, because it will just say, well, you know, it goes through and resets and sets them automatically. So I don't really need to have a clear position, so I just added this in. This actually just goes through and clears all the LEDs, but I could have just called this with 8 or 9 or 10 or something. With 9 or 10 or 11, and it would have cleared it anyhow. But that's okay, because I wanted to make it clear, and I wanted you don't want to actually know. I want the code to be written so you don't actually know how many LEDs there are on. So the game should work if you wanted to add more LEDs or reduce the number of LEDs. So what have we got at the bottom here? We've got do do, I can't actually see what it says. It says do win flash. All right, well that's just a simple thing. Well, we're going to come back to this one. That was just that, but that just flashes a particular LED whatever number of times, however fast you specified in the constant. So these are all very straightforward things here. That's the set the position, that's to clear everything, that's to flash everything, which just calls clear and set alternatively and going through a for loop. So that's straightforward. So the first page all makes sense. So I don't actually know how to do the second bit. I think I might go straight to the loop. So we're going to go to the loop page, make sure everything's on the camera. Alright, so this is, it's really important. Like, I really don't want to do this video and realize that I've missed out the top. So how this loop is going to work is, the first thing I'm going to do is I'm going to set my current speed to the, so there's actually no reason to do this. Like, I could do this, I don't know why I have an actual there, well, I do need it. I haven't quite gone through the code. I really need to have, hold on, I've just got a smart idea. Since I actually have this code printed out twice, I could have a copy for me that's the right way around. So the current speed is set to the movement update rate. So we'll come back to what that actually means. But we'll read in the current time, which is the current time we're reading in is the is using the millis function, which is the number of milliseconds, pretty much I guess since when you turn the machine on, when you turn the device on. And then I've got this next update time. So I've got these, they're all long variables, so they're all 32-bit long variables. Pretty sure they're 32 bits in Arduino land. I'm so used to Java where that would be a 64-bit number, but hey. So we've got the next update is the current time plus the current speed. So I don't think current speed, let me just double check. I don't think current speed ever actually changes, so I could have just used this constant here. So the next update time is the time when we're going to do the next update. So how it's basically going to work, but we'll go through that. We'll go through this first, and then I'll quickly go over how it actually kind of functions. We also have a game over variable, which is a boolean. We just say it's false. We have a position, which is the current position with the current LED that's on, and that's the number of LEDs divided by 2. So that's the middle LED. And we've got the maximum position, which I use later on. So I just defined it as a variable here, which is the number of LEDs minus 1. So if there's 9 LEDs, the maximum position you can have is position number 8, because you start at index 0. So you go, say you had 3 LEDs, then the actual position values would be 0, 1, and 2. So this is just giving me the actual value of the last LED. So I just use it later on. It's just better than writing -2 all the time. It's just one less calculation. So boolean, what have we got here? Upper set, lower set, upper live and lower live. So these are going to be very confusing when you first see these. So we'll just come back to them in a minute. So the first thing we do is we set the on LED to be the current position, which is, as we've gone back here, the middle LED. And now we have to go to our game loop. And so while we are not game over, so that's the exclamation mark, that means while not game over, we're going to call 2 special functions first. The first one is, both of them are called check button, and then we're going to have this kind of perhaps confusing notation if you haven't seen this before. But I did do this briefly where I use ampersands. So we'll jump over actually, and we'll have a look at what check button looks like. That will make things a lot easier. I'm just going to put some code up on the side here so I can read it upside down. Alright, so this is check button. So before I go any further, I'll just say what's basically going to happen is I have my upper set, and we have to go back to here, don't we? Upper set. We have the set, and so for both upper and lower, so I'm actually regarding this. I called it upper and lower. Probably think I should have called it left and right, but I've kind of gone with upper. So upper is the one, so this is going to be LED number 8. So let's just say this is the upper button. This is LED number 8, and the lower button is next to LED number 0. So as you're going up the LED count or position count, you have one button and you go lower to the other one as the lower button. So I'm sort of regarding this as an upper button and a lower button, where you could have said left and right. I think it was just entirely the way the wind was blowing on the day that I wrote that code that I decided to go with upper and lower. But there's two things that matter for each button. There's a boolean which is if it's set and if it's live. So I've called it live. The live part is basically so that I can't just hold the button down. So there was one really important thing I actually wanted to point out, and that is, if I hold down one button but I don't let go of it, I can still press the other button, and it goes back to the other position, and it does that only once. So the very first version I did, you could hold down a button and it would slowly move along, and that was a problem because I'd be checking one button first, and if that button moved, then the other button wouldn't be checked. So I could have actually, I don't know if I should have done that. Now that I think about it, it probably would have been easier to say, well, if you held that button down, you move that way, and if you hold down that button, you move this way. So if you're holding them both down, they don't actually move. But in this case here, I don't know why I didn't do that. Maybe it makes sense as we come through it. Well, I'll just go through the way that I've done it now, because otherwise we're never going to get anywhere. So we're going to look at check button, which is not this one. That's my other printout. But we're going to first be confused by the parameters to the function. So the parameters to the function, the first one is a byte, and it's the button pin. So that's pretty straightforward. And as you can see, looking at the actual code, when we call it in the first case, we're just passing in that constant, which is the lower button pin. So that's all sensible. But then we've got here the stars. And so we're actually not passing in a boolean. So this is where it gets kind of confusing if you haven't done this before. You're not passing in a boolean value. The value you're passing in. So when you call a function, you always pass in. So where's an example? Actually, I was going to show an example. So looking at the first page, which is this. Right, here we go. It's this page here. So looking at this first page, down here, I call the set position function with the variable position. Let me make sure it's on the screen. But I'm not passing in a variable. I'm passing in the value of the variable. So if I was in here in my set position thing, and I change the value of pos in here. So say at some point in this code I had pos equals 7 as the last number. That would never change the value of position, because you haven't passed in the variable. You've only passed in the value of the variable at the time you called it. So if position was 3, when you go to set position, pos will be 3. That will go into that variable. And if you change that variable to 7, that doesn't matter, because when you come back to here, this is still 3. It always will be 3 down here until you change it in this bit of code, because you're passing in the value, you're not passing in the variable itself. But I'm trying to do something different. I'm actually trying to essentially pass in the variable itself, and I can't strictly pass in the variable itself. Where is the code? But what I can pass in is, how much time? We've only got 9 minutes left. We can pass in a pointer to the location in memory. So all data in the computer's memory, including a little Arduino, is at some location in the RAM. So that's designated by a number. And so what we're going to ask here is not for the actual value for our value. We're asking for the value of the location. So what number is the location of this thing that you want to pass in? And I want something that points to a Boolean in these cases here. So what I do end up calling, so that's what the ampersand symbol back here means. It means don't pass in the value of upper set, pass in the location in memory of upper set. So I will come back and actually talk about why what I'm doing here can be very tricky if you don't do this properly, because I'm using a local variable within a function and I'm passing in the memory location of that. But we probably won't be able to do that on this video. But so in this case here, I'm passing not the value of upper set, I'm passing the location of upper set. This thing is asking for the location of a Boolean. And then we're actually going to, so what we do, if we pass in the location to where that variable is stored in memory, we can actually change the contents of that location, and that will change the value back here. So this is basically a way of using a function that returns more than one variable. We're returning all the values in here and changing. In this case, we're getting as input the values in here, and then we're possibly changing them later on. If you're not going to change them, you probably would not do that. You would just pass in the actual value. So what does check button do? So I think we're probably going to run out of time. We'll just quickly go through what check button is. So basically I say, well, if the button pin is down, right, so if it's down, we're going to do this bit of code here. So I need a little pen, don't I? So if this button is down, alright, so that's that bit there, and this is this bit here. We'll do, so there's actually an if within an if. I just found this pen on the ground like recently, so I don't know if it really works. So if the pin is down, so this means if I press the button. So if the other, what's it called? Other set var. So this is the other set variable. So set is saying whether or not I have held down the button and it is set to be moved. So it is set as a movement option for the next update phase. So this, and the way that it's working is it's not updating all the time, it's only updating every so often. And by every so often I mean, like, 20 times a second, 30 times a second. So we're just saying, well, was the button set for the next update time? That's what the set is holding. And live is actually holding, is it valid to check whether or not the button is held down? And just to jump ahead, so the live, once a button is not being pressed, then it is live. But if the button is pressed, then it becomes non-live, and it can't become live again until you've let go of the button. So this thing here says, if I haven't set the other button, so the way of reading this, if I haven't set the other button, I'm going to read this. Oh, right, that's a not sign. I thought it was an I. I thought, why was there an I there? So if it's not the case that the other button is set, alright, so when we have the star, we say read in the value from this memory location and treat it as a Boolean, because remember, this is not the value of the variable, this is the pointer to the variable. This means here, when you have the star here, it means read in the value of the variable and then treat it as a Boolean, because it's pointing to a Boolean, and then you're notting it. So you're saying if not the value of the other variable, so if the other variable isn't pressed down, isn't set up, and I'm currently live, all right, then I'm going to set my set status to be true. So I'm going to say that I am set up to move, and the live, I'm going to say I'm no longer live. And because I'm using the star here, I'm actually changing the value in the calling function. So I'm actually changing this variable here over in this code here. So these are the things I'm actually changing here, because I'm changing the value at the location pointed to by these variables. So in this case is not passing by value, I'm passing by reference, so I can change these things around, which is a strange way of doing things if you're not used to it, but it can be useful, especially if you're writing hacky C code to do this kind of thing. So I didn't actually originally do this, I actually had it, but it was all, the code was just a little bit too big, so I broke it down into a function, but then because I wanted to change 3 things at once, I had to do it this way. And if you don't have the button pressed down, so if the button's actually if you've actually let go of the button, then it becomes live again. And so then you are able to, so if you press it down, as you see later on, it can become unset. It becomes once you've moved, it becomes unset, but it's still not set. So you move once, it's no longer set, but it's still no longer live, and it will remain live. The only thing that can put it back to being live is this line here. So this is sort of like stops it from moving more than one time. So you have to keep pressing, you have to let go first before you can go to the next part. So we will come back to this bit of code perhaps a bit later on. But the reason I've got it here is basically I check the button so there's probably a slight bias here for if you accidentally, at any one fraction of time. So this game loop is going around many as fast as it possibly can, and it's done many times. So you're not actually pausing. There's no delay function in here. So I am twirling this really fast. I'm only actually moving things every so often, which is what this bit of code is for. But we'll come back to that next time because we'll run out of time. So the point is, there is one little small problem. This thing here we'll call the check button. That will see whether or not this button, upper button, is pressed down. And if upper button is pressed down and the lower button hasn't been set yet, so I do need to just quickly show the order of parameters. I'll put them down like this. So we've got my set thing. So if I'm looking at the upper button, then upper set is my set. The other button set thing variable is lower set, and my live is upper live. So this is basically going to say if the lower button is not set and the button is down, then I will make upper set to be true, and I will make upper live to be false. And if upper button happens to be not pressed, then I will make upper live to be true. So if that makes sense. And then I'm doing the exact opposite in the case of the lower button. So I'm going to check this. So there is a small race condition, which is if you happen to press both the buttons at the same time and neither button had been pressed previously, so the last time we went through this loop, no buttons were pressed and they were both live. We would set the upper one first and then we wouldn't be able to set the lower one, because when we come down to check the lower button, we'll say, oh, well, upper's already set. But I think that's highly unlikely, and so won't make any effective difference to the actual game. But this could be a problem if you weren't actually doing it very fast. So if you weren't updating very fast, then that would be a slight issue where you would have a slight bias towards the upper player. I don't know if that makes any sense, but we'll come back to it and I'll think about anything I haven't explained very well. But we've still got to explain the rest of the code. So we'll save that for another day or tomorrow. So thanks for watching, and bye.